Okay, so this is to help with number 6 from the homework. This is the other kind of Rice chart problem. So it's for the system, if we start with the initial concentrations of H2 and CO2 at 0.16 molar, what are their concentrations at equilibrium, given that the KEQ is equal to 4.0? So this is a type of Rice chart problem where instead of solving for KEQ like we were doing previously, they're providing us with the KEQ and they want us to calculate the concentrations at equilibrium. So again, this is helpful in terms of predicting what the equilibrium concentration should be when the system has reached equilibrium. So to do this problem, write out the equation, and you want to do the acronym of RICE, R-I-C-E. Remember, that stands for the reaction, the initial concentrations, the change in concentrations, and then the equilibrium concentrations. This is what we're interested in. We want the concentrations of all of these species at equilibrium. So first up, we're going to put in the values that they give us. They tell us that H2 and CO2 are both 0.16 molar. So we know that this can be 0.16 molar, and this can also be 0.16 molar. The initial concentrations of the products are assumed to be at time equals 0. We don't expect to have any appreciable amounts of either of these. So both of those are just going to be 0 molar. Now the change in concentration, remember, is stoichiometrically based. We expect the reactants to decrease by some factor that's stoichiometrically based, and we expect the products to increase by some factor that's also stoichiometrically based. Now we don't know what that number is quite yet, so we're going to put it in terms of x. This problem is an easy one because everything is just 1 to 1 to 1 to 1 right across the board. So we expect the reactants to decrease by a factor of 1x. So both of these are just going to be minus x. Both of these guys over here are just going to be plus x. Because again, everything is 1 to 1 to 1. Now you'll notice they don't give us any information in the problem for an equilibrium concentration. Like we don't have any of these 4 species values at equilibrium. That's different than the previous problem we looked at, where we were given one of the equilibrium concentrations, and that allowed us to solve for x. So we don't have any of these values currently, but we do have the KEQ value of 4.0 over here. So the best that we can do right now at this moment is to put the equilibrium concentrations in terms of x. So we're going to call this 0.16 minus x. This will also be 0.16 minus x. This will just be x, and this will also just be x. So to figure out the equilibrium concentrations, we obviously need to solve for x. To do that, we're going to use the KEQ value we have over here to help us algebraically solve for x. To do that, we need to write a KEQ expression, which is law of mass action, products over reactants. So it's the concentration of CO2 to the first power, concentration of H2O, also to the first power, over the products, which is concentration of H2 to the first power, and the concentration of CO2 also to the first power. So it's really helpful to write out your KEQ expression generically before you plug values in, especially if we're dealing with coefficients that aren't all equal to 1 in this case. It's really important that you have the exponents correct over here before you plug things in, just to remind yourself of what the exponents are and to do PEMDAS order of operations correctly. So now that we have this set up, we can plug in actual values. Our KEQ value is 4.0, so we're going to do 4.0 is equal to, at equilibrium, both of these guys are equal to x. So we're going to do concentration of x to the first power times concentration of x to the first power, divided by the concentration of H2 is 0.16 minus x to the first power, and then 0.16 minus x also to the first power. Now we need to simplify this to help with the algebra. So we're going to do 4.0 is equal to x squared over, now your first inclination is probably to FOIL this. We don't want to do that because we'll get a quadratic. So what we're going to do is actually take this and go 0.16 minus x quantity squared here, kind of backwards of what you probably do in math class. And that allows us now to simplify in terms of x without having to deal with a quadratic. So in this next step here, we're going to want to square root both sides to get rid of the exponent. So we'll look something like this. You're going to end up with some not so friendly numbers. Let's see, what do we got? 2 equals x over 0.16 minus x, which I guess is not horrible. And then from here, we have to do some algebra in order to solve for x. So the first thing we should do is multiply both sides by 0.16 minus x. That will clear the denominator, right? Cancel, cancel. over here, multiply by 0.16 minus x. So we're going to end up with 0.32 minus 2x is equal to x.